Adding and subtracting radicals is very easy, especially because it's just like combining like terms. Let's take a look at this property. Notice how you have the nth root of a plus nth root of a is equal to 2 nth root of a. This tells us two things. First off, when you add radicals, you need to have the same index. You cannot add a square root and a cube root together. Second off, you have to have the same radicand. Now, what is a radicand? Well, basically, that's the stuff inside. Square root of a, square root of a. Like terms, basically. When you do that, this is like having x plus x is equal to 2x, but it's 2 nth roots of a. Let's apply this property to simplify a couple of radicals. Right off the bat here, these are both square roots of 7, so they can be combined together, and 5 plus 9 is 14, so we have 14 root 7. For this next problem, we have 2's inside each radical, but the center one is a square root, whereas the other two are cube roots. So the two that are cube roots can be combined together. We subtract to get 3 cube roots of 2, but then the 7 square root of 2 must be on its own because it's not a like term. It does not have the same radicand. For number 3 here, these do not appear to be combinable. However, if we break these down, notice this 80 can become a 16 times 5, and 45 can become 9 times 5. 16 is the square roots into 4 times 4, and that 4 will come out and multiply with a 3 that's already out there and give us 12 root 5. Likewise, the 9 is 3 squared, and so we have a pair of 3's that come out as a single 3, multiplied by the negative 5 that's already out there, and give us negative 15 root 5. Now we have square roots of 5, which have the same index and the same radicand, and we can subtract and get negative 3 root 5. Let's try this again with the next problem. 72 breaks down to 36 times 2. 8 breaks down to 4 times 2. And 50 breaks down to 25 times 2. And when a number comes out of the radical, it multiplies with the number that's already out front. So when we have this 6 coming out of the radical, the 6 multiplies by the 7 and gives us 42 root 2. In the middle here, the 2 comes out. There is no number to multiply by, so we have minus root 2. And then 25 comes out as a 5, multiplies by that 4, and gives us plus 20 root 2. Now we see that all of these are square roots with the same radicand, and we can just subtract across. 42 minus 2 is 40, plus 20 makes 60 root 2. For this final problem, we have a cube root inside here. 64 is 4 times 4 times 4, and so a 4 can come out front. Now, x to the 5th, we have 5 divided by 3 gives me 1 remainder 2. So I'm going to have 1x coming out with the x that's already there, giving me x squared, and I'm going to have 2 left inside, so x squared, and y squared also, it appears. Okay, that's simplified. Now we move on to the next one. Nothing can come out because these are both squares inside of a cube root, so we're just going to have the minus x squared cube root of x squared y squared coming down, no changes at all. With 64, 64 is again 4 times 4 times 4. The 4 comes out, multiplies with a 5, and gives me a plus 20. I'm guessing I'm going to have the same radicand because these problems are rather contrived. X to the 8th, 8 divided by 3 is 2 remainder 2. So I'm going to have an x squared on the outside, cube root of x squared y squared. Now notice what we have. We've got the same radicand. I left off my little cube root symbol there on the first one. Notice how I'm double checking that as I work through here. And we're going to have 4 of the x squareds minus 1 of the x squareds. We're down to 3 of the x squareds. Plus 20 gives me 23 of the x squareds times the cube root of x squared y squared.